Hi everyone, welcome back. This video is going to focus on average rate of change, but in a context of a word problem. And so let's see what it says here. It says the number of bacteria in a culture increases rapidly. The table below gives the number n of t of bacteria at a few times t in hours after the moment when n is 1,000. So as you can see here, there's a table where it kind of tells us what happens after time passes. So at 0 hours, we have 1,000 bacteria. That's what this first row represents. At 3.1 hours, we have 1,589 bacteria, and so on. So this table just kind of gives us an idea of how quickly the bacteria is growing. So for part A, it says find the average rate of change for the number of bacteria from 0 hours to 3.1 hours. So if you recall, average rate of change is very similar to the slope formula. Now we don't usually say slope whenever we talk about average rate of change because slope is constant. And what that means is that the slope never changes. So how quickly something increases or decreases at the same rate. But average rate of change means there could be some variability there, meaning that it may not increase the exact same amount every hour. So if we look at this chart here, we know that we can use the slope formula to kind of get the average rate of change. So the slope formula, if you recall, is y2 minus y1 over x2 minus x1. And so here's the thing. Whenever they ask for average rate of change, they always give you your x values. So here they're saying from 0 hours, so 0 hours, to 3.1 hours. Okay? Now here's the thing. Those are your x values. Okay? In this case they call it t, but it's really like your x. We need to make sure to use this formula here to find our y values. Well, the y values correspond to those x's. So y2, and if we label like this is the first point, this is the second point. y1 would be 1,000, y2 would be 1,589. So if I continue with this, it would be y2, so 1,589 minus y1 over my x2 minus my x1. Okay, and so let's simplify that. So 1,589 minus 1,000 is 589, and 3.1 minus 0 is 3.1. We can divide that out, and what do I get? I get 190. Now what does this represent? It's 190 bacteria for every hour. So again, average rate of change means how much it's increasing about, right? So it's increasing about 190 bacteria for every hour. So there we go, that's part A. So now what we're going to do is we're going to look at part B, and it's a similar thing, but here notice they give you, or they want to find the average rate of change, but now they give you different hours here. So we have 6.2 hours to 15.5 hours. But the idea is the same. We're going to do the same thing. We're going to take values from the chart. So let's go back up to this chart here. And let's see, we are now going to focus on 6.2 and 15.5. Okay, so if this is my x1 and this is my x2, we got to find the y values that correspond to that. So this would be my y1 and my y2. So now when I use the slope formula again, I know that y2 is 6,425, and we're going to subtract my y1 value, so 2612, and then we're going to divide by my x2, which was the 15.5, minus my x1. So at this point I encourage you to pause the video, simplify this, make sure you can simplify it well, and check back in a moment to see if you got the correct answer. Okay, welcome back. So as you can see, this is my work. I simplified the top, so I got 3813 at the numerator and 9.3 in the denominator. And when I divided those out, I got 410 bacteria per hour. So that is the average rate of change for the number of bacteria from that time interval there, from 6.2 hours to 15.5 hours.